Okay, thank you so much. And then this file of recording will be uploaded into the Elok platform. So if you all missed the session, you can rewatch it on Elok. Okay, so don't forget to all participants that haven't joined the course in Elok yet to join immediately and take note for each segment. This first topic session is about implementation of smart agriculture concept based on integrated farming, which will be delivered by our speaker, Professor Dr. Engineering Lilik Sutiarso, Master of Engineering from Faculty of Agricultural Technology, Universitas Gadjah Mada. Also, this session will be led from our moderator, a lecturer from the Department of Agriculture and Biosystem Engineering. She is Dr. Priska Rinda Lestari, Bachelor of Engineering, IPM. The operator team, can you show the CV of the, okay. Okay, this is the CV of the Dr. Priska Rinda Lestari. She is the lecturer of the Department of Agriculture and Biosystem Engineering, Faculty Agricultural Technology, Universitas Gadjah Mada. And education, she is in Bachelor in Environmental Engineering 2016, and then Master to Doctoral Environmental Engineering in 2021. The achievement, the best research Indonesia among the 2019 Kurita Overseas Research Grant recipients 2021, awardee of PMDSU Scholarship and Research Grant from the MAC3 2017 until 2021, and then awardee of Kurita Overseas Research Grant, and then about 3 other achievements. And the publication that has been shared by Dr. Priska Lestari, you can also see on the screen. And that's all for the reading of the CV of Dr. Priska. And then, don't wait any longer. I will introduce to you Dr. Priska Lestari. The time is yours, please.
Thank you very much, Mr. Resnanda. Does my voice clear? Can be heard clearly? Okay. Good morning, everyone. I'm Priyaska Lestari from Department of Agricultural and Biosystems Engineering, Faculty of Agricultural Universitas Gadjah Mada, and also welcome for all of the participants of the 5th summer course 2023. And today, this morning, I will be the moderator for the first session that will be delivered by our first speaker, our guest speaker, Professor Dr. Lilik Sutiarso, with the implementation of smart agriculture concept based on integrated farming in Indonesia. First of all, I would like to remind all of the participants to check the Elok system regarding the material, assignment, and other information. And also, I would like to remind all of the participants to don't forget to follow the Instagram of the summer course, Faculty of Agricultural Technology, UGM, and also update all of your information by mentioning in the Instagram. And also, before we would like to starting our first session, we would like to welcome Professor Lilik. Good morning, Professor Lilik.
Okay, morning, Mbak Priska.
Okay.
See you.
First,
Long time no see.
Long time no see. Okay, before we start, we would like to read the curriculum vitae or the CV of our invited speaker. Okay. Our first speaker in this morning is Professor Dr. Lilik Sutiarso M.Eng from Agriculture and Biosystem Engineering, Department, Faculty of Agriculture Technology, University of Gadjah Mada. He earned educations in Bachelor in Agriculture Mechanization, Universitas Gadjah Mada, and continued the Master in Agriculture and Food Engineering in ASEAN Institute of Technology, Thailand, and finished his PhD in Bioproduction and Agriculture Masonry, University of Tsukuba, Japan. We also know that our incredible speaker today has an amazing professional skill and expertise from precision agriculture, smart farming, system analysis, and agriculture mechanization. And they're also a major achievement from the first is a research grant from Myanmar Environmental Sustainability Support Association, or YESA, from 2018-2022, patent on design of Gadjah Legowo type riding rice transplanter, 2018, research grant from Navik Neso, Netherlands, 2019, research grant from STFC Food Network, funds University of Sheffield, UK, and professional engineer certified by the Institution of Engineer Indonesia 2017. And this is just a beginning, and we will start our discussion will be delivered by Prof. Lilik. And maybe the time is about 60 minutes, Prof. Lilik, and I will remind you maybe in the last 5 minutes before the discussion is end. Please welcome Prof. Lilik for your amazing presentation.
Okay, thank you, Mbak Priska. Assalamualaikum warahmatullahi wabarakatuh. Good day, all participants, fifth summer course. I'm very glad that, this amazing opportunity that I've to be a first speaker in this event. So thanks for all organizing committee, of course, Dean, Vice Dean, and all committee. And also that welcome all of you, all participants, however, only in Zoom meeting, but I hope that next time that you can come to my campus, and we can learn together, we can work together with, we have many, opportunity to do research or maybe community development, something like that, that we can, especially that to strengthen our networking, between Universitas Gadjah Mada and your university. Okay, because time is limited, that I'm very sorry that I have to turn off my camera, because now I'm still far from Yogyakarta, so I'm afraid that the internet signal that's very weak. So I will turn off my camera during my presentation. Okay, can I share my? Okay. I'm sorry. It's already.
Yes, we
Okay,
can see the.
And also my voice is clear?
Yeah.
Okay.
We can hear you clearly.
Mbak Priska, please give me mention if any trouble. I'm very sorry.
Sure.
Okay.
Please welcome, Prof. Lilik.
Yeah. Actually, this starting from the first summer course, second, third, fourth, and now fifth summer course, that's our faculty of agriculture technology, and also UGM, especially that's we move now with a transition from conventional agriculture to smart agriculture. But the problem in the field or in our society, that's we know that there are many different situation, agroecology, socio culture, something like that, or maybe agroeconomics. So that's why we give more attention how to develop, how to implement the model of smart agriculture in Indonesia. Especially we connected with integrated farming system. I hope that in this sessions, I want also learn from you that come from other country. Yeah, that's Thailand, maybe in other country. So we can make some, what is the general conclusion related with how to develop appropriate smart agricultural technology in our country, because I think it's important for us when we deliver our technology to our farmer or our society, that we have to responsible also that the technology can be implemented in the field. Yeah, maybe there's no problem if smart agricultural technology implemented in Japan, for example, in a modern country, for example, or in a country that has advanced in technology, high-tech, yeah, Korea, etc. But the question is how to develop, how to design the smart technology, especially in agricultural sector in our country, in developing country. Yeah, you know that in Indonesia we have maybe thousands of islands, from Papua to Sumatra, from east part to west part. We have many thousand island. That's also, of course, they have what is the many characteristic related to social culture, related to socio-economy, something like that, or climate, agroclimate, something like that. So that's why in this the first session, that I would like to share our experience, our research, yes, related the how to implement the smart agriculture concept based on integrated farming in Indonesia. Okay, yeah, this short my short curriculum vitae is already mentioned by Mbak Priska before. Yeah, I will start it in these pictures related to Industry 4.0. I think that's you already familiar with this picture, yeah, this graph. That's, yes, of course there are many questions. Yeah, what is the transition from first, second, third, and the final, and now we are coming in fourth industry era. Yeah, so I think the important question is what is the difference between what is the industry 4.0 to compared to third or second or first industry era. Yeah, so now we are in industry 4.0. Yeah, this concept. Yeah, this I think in this figure we know that there are what is significant characteristic if we compare with industry 3.0, because you know that 3.0 we also talk about computer, we also talk about IT. Yeah, we also talk about technology, yeah, automation, etc. Yeah. But what is the difference? So maybe if you have I don't know, if you have assignment or quiz, yeah, I will ask you all, yeah, can you explain what the difference between 3.0 and 4.0? Yeah, because we talk about IT, we talk about computerization, we talk about automatization or robotics. Then I will connect with 4.0 with some attributes. Yeah, we call that there are some attributes here: automation, connectivity, cloud computing, IoT, big data, and then system integration, etc. So if we group or categorize, that's there is area of concept. Yeah, Industry 4.0 is or the cyber physical system is a concept of a 4.0 era, and here this is the attribute. Yeah, tools, technology, instrument, etc. Yeah, so there is close connectivity between concept, industry 4.0 and attribute and its attribute, tools, etc. So if we are discussing with industry 4.0, so maybe this related to IoT, related to artificial intelligence, big data, something like that. Yeah, this. But once again, I want to ask you, what is different between 3.0 and 4.0? Yeah, maybe later we can discuss. Yeah, first era, second era is okay. Yeah, in the first era we talk about mechanization. Second era we talk is electricity. But in the third, we come in computer technology, we come in robotics technology. Yeah, of course, also develop or related with agricultural sector. Yeah, because we know that the agricultural activity or agricultural sectors is one of sector in industry system. Yeah, maybe next speaker or next letter, that's why agricultural sector one of part of industry. Yeah. Okay. Then next. Sorry. Okay. And also we talk about revolution from society 1.0 to society 5.0. Yeah. We know that in these figures there is a transition also 1.0 to 5. Yeah. We know that I think this is a topic of 5.0s. We call the smart society. Yeah, there is a smart agriculture 4.0 in there. Yeah, in it IoT, big data, artificial intelligence, robotics, etc. But in the society 2.0, we know that we have agrarian society. Yeah, so once again, that's what the different society 2.0 in agrarian society with compared to society 5.0, yeah, smart society and smart agriculture. Yeah. So if we know that the society 2.0 or agrarian society, they conducted the conventional agriculture. Yeah. But in 5.0, yeah, we can call the smart agriculture. Okay, and the staging from agrarian society, yeah, and society 5.0 or smart society, yeah, we know that there is, if we figure, something like that, if we drawing something like that, there is a gap in socioculture value. This is the important thing that we have to know, that there is a gap in socioculture value, not only technology value, but the important things that we have to know what is the impact or the effect if we transition, we transform from 2.0 to 5.0, or maybe society 4.0 to 5.0, information society to smart society. It's always there is a gap value, in socioculture, in education, in technology, etc. So that's why I will more focus, to consider the main, the important aspects related to socio-cultural value. Why? Of course, we have many differences point of view, especially if we understand of the meaning of agriculture. As you know, that maybe you can also Googling in some internet source. Agriculture is derived from two Latin roots. That's agri is meaning is field or area. Culture. We have two terms related to culture. The culture first is cultivate. So we talk about technology, we talk about methods, or we talk about how to, how to fertilize, how to soil tillage, how to harvest, something like that. And the second is, culture is the meaning of way of life, cultures, or local wisdom, or community or society behavior. So that's why if we talk about agriculture or biosystem now, we talk about culture, we talk about local wisdom, behavior. So that's why we cannot make a generalization related to the condition. All, for example, in Indonesia, from east part to west part, is many characteristic, local characteristic, local wisdom. We cannot make a general. We cannot make a development model in agriculture. This is a modern agriculture related to system approach thinking. That's actually, if we talk about modern agriculture, we talk about shifting, paradigm shifting. Not only talk about technology itself. But if we are in modern agriculture, this the paradigm shifting in agricultural development is indicated by the process of transformation from traditional to modern agriculture. To increase, I think important here that not only about productivity, not only how to increase quantitatively productivity, but also sustainability. That's the main indicators in modern agricultural system. Not only how to increase productivity, but also sustainability. And now maybe more wide talk about what is the environment, sustainable environment, something like that. So that's why this there is transition process from conventional agriculture to modern agriculture. Now, we try to make some concept of smart agriculture, Yeah, that's in the beginning that I already mentioned. That's how to develop the appropriate smart agriculture, because you know that we cannot make a generalization of technology, of smart technology. So in our concept, that's at least there are three steps in smart agriculture. First is, sorry. First is we have to develop that management of information and knowledge, because why? That's we know that each area, each region, yeah, there's no local knowledge that's different with other location. So that's why we need build, or we need design to design the management of information and knowledge. So we have to make, or we have to build a data-driven system. That is the first step. And then the second, there's precision agriculture. Yeah. The last is automation and agricultural robotics. So that's why if we conduct, or if we develop the smart agriculture, I think we have one by one, step by step. We cannot jump to robotics technology. We cannot jump to automation technology without we develop the management system of information and knowledge, or make some design of precision agriculture. So this the three step, the platform of smart agriculture, and of course it's different with one area to others. Yeah, develop a model. Sorry. Develop model of integrated smart agriculture, especially in Indonesia, towards the era of digital agriculture. So at least there are three subsystems, automation, culture, one skin, because why? We talk about agriculture. So we cannot separate the social culture. And this is the main main aspect if we talk about agriculture. And the third subsystem is environment. Yeah, three subsystem is linked or connect each other. Yeah, we talk about automation and culture, talk about automation and environment, culture and environment, etc. And you see in this subsystem culture, not only plant or animals or microorganism, but also human. It means that we have to know, we have to learn about the human culture. I think if we talk about agriculture, the farmers, we have to know what the characteristic, we have to know the behavior of our farmers before we develop the automation, before we develop the technology, etc. So that's the core of integrated smart agriculture. And also that to consider also that if we develop the smart agriculture, it's not only talk about technology, for example, drone, automation in tractors, or in other activity, both indoor and outdoor activity. But the first thing that is a mindset. We have to know that once again that the culture of our farmer, culture of our society, their mindset related to the agriculture. So and then the second layer is talk about socioculture and economic condition. We cannot push smart agriculture development without consider any consideration related to the social culture aspect or economy aspect. The third, just we talk about technology, consider about technology. So it means that we cannot directly develop the smart agriculture directly related to technology, yeah, because we can develop in particular area, yeah, with modern agriculture without any advanced technology. That's the why that in the beginning our my presentation, that technology or high tech is not one of the first priority if we develop what is modern agriculture or smart agriculture. The first thing is mindset, the farmer mindset, yeah, our regulator, industry, etc. Yeah, we have to change, shift our mindset, our shifting paradigm from conventional to modern agriculture. And the last is non-human. It's mean the infrastructure, physical or non-physical infrastructure. Yeah, that's the at least there are four stages when we move from conventional to modern agriculture, to smart agriculture: mindset, social culture, economy, technology, and non-human. There's a model of integrations, smart agriculture in Indonesia. The first is that we want to develop the humanity agricultural technology. We cannot directly develop the high tech in agriculture, but we have to consider our society, our farmer. So that's why, and the first step that we need to develop humanity agricultural technology. So you can elaborate later that what is the humanity agricultural technology. Yeah, this is the point of our presentation. That's how to develop humanity agricultural technology. The second is qualified human resource, of course, farmer, yeah, and these other stakeholders supporting infrastructure, industry, institution, yeah, farmer institution. That's we focus on learning, organization, based institution, and of course we still need that government supporting from government regulation or government policy. So there are at least there are 6 aspects to develop the integrated smart farming in smart agriculture in Indonesia. Yeah, but the first we have to develop, we have to build the humanity agricultural technology. There's also there's national strategy for agricultural development. Yeah, we know that we now it's transition from petrol-based economy to bioeconomy. So that's why our field, yeah, related to agriculture, related to biosystems, you know, have first priority in especially in Indonesia. Yeah, and the second is monocrop system to integrated. So we move from monocrop to integrated. Sorry, wait a minute. Sorry. Okay, sorry. I will continue. That's the third is we talk about sustainable bioindustry system to minimize waste, chemical inputs, environmental friendly, added value, product diversification, supply chain management, especially our colleagues from agriculture industry technology, they focus in supply chain management. So I think there are some transformation, the conventional agriculture to modern agriculture. Not only talk about productivity, but also sustainability, with some added value and something like that. Okay, yeah. So the concept of integrated farming system, there are three aspects, socioeconomic aspect, socio-culture, economic aspects in the first aspect. In the second, of course, agricultural and environment aspect, and the third is engineering aspects, because you know that from engineering we can develop the technology. Engineering and technology is closely related, so we cannot develop the smart technology, we cannot develop the advanced technology, for example, without any engineering aspect. And so there are three subsystems in integrated farming system. This the concept how to develop the area of smart integrated agriculture in the right side. So please, you can see that's how to make or how to develop, how to design the smart integrated agriculture. Starting from planning, cultivation, post-harvest, distribution, marketing, then also smart urban city farming, etc. But in order to develop the area of a smart, we need technology. We need smart technology. For example, artificial intelligence, IoT, automation, robotics, cloud computing, this attribute of Industry 4.0 era we talk about previously. If we what is the of course the level of technology will be give effect. That's how to manage the natural and human resources, of course. And also that's now without any technology, this agricultural system in existing condition, without any intervention, the smart technology. But if we introduce the smart technology, IoT, automation, robotic, etc., that we can change our system, our conventional agricultural system, to smart agriculture system. This the concept of how to develop the area of smart integrated agriculture. So of course, the smart technology gave a contribution significantly in order to increase the existing system or existing condition. We can see some example in every country, of course. How to manage natural and human resources. But if we interfere or if we introduction with smart technology, so we can change the situation on the system from conventional to smart integrated agriculture. This in UGM, so we will invite all of you, if you have interested to develop smart smart agriculture system. We develop in our laboratory, in our department. We call smart agriculture, agricultural and biosystem engineering, UGM. You can join with us, to learn together, conduct research together. That's we connect also our instrument, our technology with Kyushu University. Yes, maybe later that our colleagues, Professor Okayasu, Okayasu Sensei, in Kyushu University, that we already connected our networking, smart system or smart technology networking. So please, we invite all of you in has interest to develop together the smart technology in agriculture. Maybe briefly, that's Indonesia. That's we have 200 million hectare land territory and 25% agricultural activities. But unfortunately, that still that 15.40 for contribute to GDP. Is maybe number 3 or number 4 compared to industry, transportation, etc. I think this our homework is how to optimize the natural resource, human resource in Indonesia related to how to increase or how to move from conventional to modern or to smart agriculture. There's pro and cons related to tropical agriculture production in Indonesia. That of course we have some benefits. The tropical climate, availability of the sunlight throughout the year, employs much labor. You know that we have I'm not sure that now maybe number 5 in the world, number of population. But we have also some challenge, that's limited natural resources, limited of tools, technology, and capital. So I think this our challenge, that that we have to move from 3.0 or 2.0 to 4.0 industry era, but we realize that we have some limited tools, technology, capital, of course, limited of knowledge in adoption of new technology. So in one side we have some benefits, but in other side that we have still also challenges. If we talk agricultural production, this will adapt to the dynamical environment, especially now that's in farming management, climate change. So we need that farmer wisdom, local wisdom. We cannot solve the problem only with technology. But the most important, once again, that's the farmer wisdom, local knowledge. It's very important to adapt or to justify that we have some dynamical environment. Also, once again, that climate change intensifies that unpredictable weather and unstable climate system distribution. I think it's also our challenge now. Maybe not only in Indonesia, but all over the world. That's climate change, especially related to agricultural things. We have to mitigate the problem, mitigate the situation. Climate change. Smart agriculture was considered to improve the farming management by optimizing. So once again, that the keyword is how to optimize the resource. I think this is the key of our main indicator in the smart agriculture. We are not talking about maximizing or to minimize the resource, but optimizing. But to optimize the resource, both in natural and human resource. Through the utilization of ICT or information technology, I think, of course. We try to make some concept that's related to the appropriate adaptation of smart agriculture can be visualized into 3 stages. First, still some bahasa. First is, the first priority is related to human resource. human base. So we call humanware. And the second is talk about technology, and the third, the main of in smart agriculture is knowledge-based system. Yeah, so we divided into 5. Yeah, humanware, hardware, software, infoware, and organoware. Yeah, this from conventional to smart technology to smart system. Of course, we still have some gap analysis. Yeah, from how to develop the human resource, yeah, until we develop the local knowledge base. Yeah. And maybe in the, you know, also that you can elaborate or find in some internet research that's the first priority industry, of course, in era 4.0, that's food and beverage. So we are glad that our field, our interest field, that related to agriculture, related food, etc., that the first priority in industry 4.0. So that's why now we move from agricultural production to agroindustrial system. Yeah, we are not can only sell the fresh product after harvesting, but also we extend our activity until the industry in agriculture materials. There's also some figure that digital transformation of agri and food in 4 areas. One again, that's the first is decision making process. Second is food integrity. Third is public, related to food safety, environment, nutrition, climate, health, food security, and fourth is science and technology. So in this 4 areas, we can develop our IT, our digital transformation, at least in 4 areas. How to make a decision, optimum decision, food integrity, start from on-farm to ready to eat, is food traceability. And the third is public decision making, and fourth is science and technology. There's some example that we developed some model of integrated farming system in. Once again, that we are not talking about high tech, but we talk about appropriate technology in agriculture. The important thing is how to move, how to save the farmers' mindset from monoculture to multi-culture, from mono to integrated farming system. So that's why, step by step, we work together with our farmer, our community in the rural area, especially, to introduce the new technology, to introduce the from conventional to modern. Not we are not talking about the high tech. We are not talking about the sophisticated technology, something like that. That's the important thing that our farmer can give some advantage, added value, and also give a contribution to sustain the environment. So that's why the technology of waste treatment, for example, agricultural waste treatment, we can introduce to them. There's also some example that we collaborate with our colleagues in Japan, Yanmar, to develop the area of integrated agrotourism. Not only the vegetables, but also fruit, durians, and also the forest area. So we connected one system to other system. This is integrated activity that we need. That, of course, we have to introduce, we have to strengthen the smart technology, smart agriculture. But once again, that we have to know first the behavior, the culture of our farmer. Yeah. In other area, that's we develop smart agro technology. Yeah? There's some subsystem, agroindustry, agroeducation, agrotourism. Yeah? We develop in one city in East Java province, Gadjah. Yeah, that's we, yeah, of course, collaborate with local government to develop the area, and the area to be a smart agro technology, or smart agro industry. Yeah, the last my presentations conclusion of smart agriculture. So first, that we have to understand the farmer first. Yeah, I think it's more important that if we want to develop the smart agriculture system in a particular area, please understand the farmer first. Yeah, there is no one size fit for all solution. One area, of course, there's particular solution. Yeah, you cannot make a generalization solving to our farmers. Farmer requirement will differ based on the range of factors. Yeah, many factors already discussed. Such type of cropping system, market access, knowledge of farming practice. The second, innovation. I think is the most important. Yeah, innovations not only talk about high technology, yeah, but maybe innovation with tailor-made solution. Yeah, solution design need to account for farmers, yeah, particular limitation and needs. Finally, yeah, if any question, that's how far along is Indonesia in the smart agricultural technology development? Yeah, frankly, that's not far enough. Yeah, that's, you know, that Indonesia's a big countries, thousand number of islands, maybe hundreds or thousand. A socio-culture condition, yeah, ecology, agroecology, something like that. So we have to, yeah, step by step to develop the digitalization. And the last, my presentation, innovative product and services, of course, business model, because we have to also consider the economic aspect, yeah, economic sustainability, yeah, and then also business process, improvement along the value chain, smart agricultural technology to enhance process efficiency and eliminate waste, yeah, because talk about a sustainable environment. Okay, thank you very much. It's my presentation. That I hope that once again that we can work together. Yeah, our laboratory, our department invite all of you to work together to conduct the research together related to smart agriculture. Thank you, Bu Priska.
Okay, thank you very much, Prof. Lilik, for such an inspiring and very amazing presentation. I also get a very new insight that maybe all of the people here thinking about smart agriculture is always using advanced technology, always using IoT and so on. But actually, the principal things about how we encourage and involve the mindsets, the resource, and the optimization. Okay. Therefore, we would like to continue for a question and answer session. So, for all of these participants, if you would like to ask any questions or please write in the chat room, or maybe you can ask directly by raising your hand. Okay, there's one participant, Komang Putra. Okay.
Okay, please.
Okay.
Komang.
Please, Mr. Komang Putra, for your question.
Okay, thank you. First of all, I'm sorry I cannot use background because I use a smartphone in this session because my laptop is not good. I have a question regarding to this really interesting lecture that given from Professor Lilik. Thank you for the material.
Okay.
That related with the smart farming. My background is a student in Tadulako University, and also I have a job as a farmer too, helping my parents, small coffee plantation. When we look in the field, I mean, in reality, that this smart farming is not applicable because lack of fund capital, also that is not accessible for our small household and society. Maybe this smart farming only can applicable for industrial scale, in this case IoT or something like that. But I have a question. Maybe in the future, 2050 or 2100, maybe all of maybe many of local farmer or small household can apply this smart farming technology. Do you have any suggestion or recommendation to our household or small farmer how to enhance this IoT, or we can apply this system in small scale? That's my question. Thank you.
Okay, thank you, Mr. Kamaputra, for the
Thank you.
question. So the question is
Directly?
that, yeah, maybe you
Okay,
can
thank
answer
you.
directly.
Okay, thank you, Mbak Priska. Yeah, thanks. Can I call Mas Komang? Mas Komang. Yeah, it's good question. That's once again, that's until now that if we talk about, if we discuss or something like that about smart agriculture, in our mind, or it is about the high technology, digital technology. But and then the question, like Mas Komang mentioned, that's how to develop, how to introduce smart agriculture in the farmer. Yeah, for example, okay, maybe in Java, yeah, or in industry sectors, maybe they use or they introduce high tech is no problem because investment, something like human resource knowledge, etc. But how to develop in the farmer level, household, yeah. So once again, that if we talk about smart agriculture, modern agriculture, or something, that's the first is mindset. The conventional agriculture only talk about how to increase productivity once, yeah, only once, how to increase with fertilizer, with many things. That in the mindset of the farmers, how to increase productivities. But if we move to modern, to smart, yeah, something like that, that's not only in, yeah, of course, productivity is one important point, but it also the quality of our products. So that's why post-harvest technology is very important now. Yeah. And the third is sustainability. Yeah. You know that maybe Mas Komang can see some sample in Sulawesi or in other area. Yeah. Now our environment, yeah, become, yeah, maybe erosion, yeah, landslide, something like that. Yeah. And due to the inappropriate agricultural practice. Yeah, so that's one of the conventional agriculture. Because why? Yeah, our farmers, yeah, always think about how to increase. Yeah, so that's why. Now, yeah, in the platform of smart agriculture, at least there are three. Yeah, first is how to develop the information, just data. We need the data, we need the information, and then we need the knowledge. Yeah, of course, if Pak Mas Komang now stay in Tadulako, ya, stay in Sulawesi, ya, central Sulawesi, ya, Tadulako. Where's okay, yeah. So of course you know very well about the farmers' behavior. Day by day, starting in the morning, yeah, go to the field, what kinds of activity, etc. So it's this is cycles of agricultural activity, yeah. But maybe someday you Mas Komang visit us in Yogyakarta. It's different, totally different. The behavior, the farmer behavior. So this the point is we have to know, we have to consider the behavior of the culture of our farmers in agricultural sectors, in agricultural activity. So that's why if we transform from conventional to to modern or to smart, something like, we have to know first what the farmers day by day, what is local culture, yeah, or local knowledge, and then we can digitalizing the local knowledge. This is the first basic of development of smart agriculture. Yeah. So that's why from the student, from alumni, from university, something, yeah, we have to how to develop the digitalizing to digitalize the local knowledge. This is the important thing. Okay, yeah. So don't worry. That's you want to develop the system, but it is the poor, for example, limited economic situation of our farmers. So the most important is how to change the mindset from productivity to sustainability, from productivity to quality. Yeah, this is my answer, Mas Komang.
Thank you, Prof. Lilik, for the answer. So we can maybe we would like to underline the important things that when we're talking about smart agriculture, it's not only about IoT, it's not only about advanced technology, but how we make sure that the necessity or a basic necessity of the farmer, especially for the socio approach and the local knowledge, is much more important than why we choose the high technology. So the clue maybe it's about appropriate technology. I think the first keyword to productivity, to sustainability, and equality. Is it can be acceptable, Mas Komang?
Okay, thank you for the answer. That is very insightful for me. Thank you.
Thank you, Mas Komang. Maybe I see there are two people that raising hand about the participants is Dennis, the first one Dennis, and is Tajudin for asking the question.
Please.
Yes.
Okay. Thank you, Professor. So, good day, Professor. My name is Dennis Prasojo from University of Gadjah Mada, from the Department of Food and Agricultural Product. And I would like to ask a question, but first, thank you so much for the amazing material. It's very insightful. So,
thank you, Dennis.
All right. So, regarding the topic of a tailor-made solution for each situation that has its own unique environment, culture, what will be your recommendation and opinion about mix matching and introducing the other farming culture that are quote-unquote similar to our farmer culture to further increase the productivity, performance, and the optimization of our own farming system. So it's like I would like to link it to the system to system approach. So what would be your opinion?
Okay, thank you, Mr. Dennis, for the question. So the next question is about not only about a system, so how to approach system, another system of the smart agriculture, and maybe your recommendation, Prof. Lilik, for implementation.
Yeah, I think yeah. Now I agree with Mas Dennis that maybe 5 years ago or 10 years ago we always what is the our approach is system approach, yeah. But starting from 4.0, we have to move, we have to change not only system approach but system of system approach. So all this the situation because more complex, yeah. In our material, the presentation material, that's if we talk about agriculture or plants or animal for something, we also that's connected with environment. We have to connect it with human resources or natural resources. So it's mean that there are many systems that we have to consider in one integrated thinking. Yeah. So that's why this the one of characteristics of Industry 4.0 era. So this is one answer in my question previously, that what the different 3.0 to 4.0 industry era. Yeah, one of the answer is we use the system of system approach because we cannot only one system in to consider, yeah, but it's maybe 2, 3 or many, yeah. Because yeah, of course our situation's more complex, yeah. We have to many aspects, we have to consider many related components, something like that. Now, so we have to design the problem solving with system of system approach. Yeah, this is the key of your question. That's how to make some strategies, yeah, to solve the problem now. Because now that's if there are some problems related to agriculture, maybe, yeah, this not only only focus in in agriculture itself, but maybe environment, but maybe our regulation, but maybe our industry. So that's why this, yeah, I think so that's why once again that we invite all of you to work together. We cannot only UGM. We cannot solve only from Department of Agriculture and Biosystem Engineering, but we have to collaborate. The key point is collaboration or working in the network. Yeah, so that is one, because all of us, yeah, have a different point of view. Yeah, maybe from industry, yeah, they will give a solution in the point of view of industry sector, farmer also, yeah, government also. So the strategy is collaboration, yeah, networking. So that's why please come to Mas Dennis is in UGM, but other participant, please, yeah, come to my campus, come to my faculty, come to my university, working together to develop, to introduce, to give assistance to our farmers related to moving from conventional to modern agriculture. That's the strategy. Thank you, Mas Dennis.
Okay, thank you, Prof. Lilik, for such an insightful answer. So, so we are not only transition from the conventional to a modern or a smart system, but we also to consider another point of view and many other aspects, especially from society, environment, and also from the agricultural engineering aspect itself. Okay, for the question, is it acceptable for the answer, Mr. Dennis?
Yes, thank you very much.
Okay, thank you very much for the question.
Thank you.
Okay, for maybe the next question is from the participants that raise hand is
From other country, maybe?
Tajudin. Yeah, Tajudin Sabri.
From
Mr. Tajudin Sabri.
Hi, Assalamualaikum, and a very good day to
Waalaikumsalam.
both doctors and
Okay.
profs. So
Yeah.
I'm Tajuddin from Malaysia, University
Okay.
Putra Malaysia, and
Ah,
basically I'm doing the agricultural waste engineering. So
okay.
I'm interested with the smart technology for the agricultural system. So as we use the IoT, so basically we as the researcher indirectly we are we are indirectly implement the IoT because we do the statistical method, we do the analysis and some more. So basically, in my question is, at what stages actually the IoT is actually need to be implemented if we want to do the smart farming? Is it during the pre-research or during the research or during the after or post-researches, which our product has been implemented to consider that is actually our research is implement the IoT? So that's would be my question. Thank you.
Okay, thank you, Mr. Tajudin, for the question. So probably the question is that in what stage the IoT should be implemented for the smart agriculture?
Okay, thank you. I think it's related to waste engineering, but Priska more expert than me. Okay, Kelihatan that Mbak Priska will also explain that. I think now we actually last year that we have a collaboration with our colleagues from UPM, yeah, in some technology that they introduced to our community in Yogyakarta. So I'm very glad that Mr. Tajudin is also join in this event that we can share our knowledge. Yeah, once again, I think if we talk about modern agriculture or smart agriculture or integrated agriculture farming system, that one of the key indicators is sustainability. Of course, we focus on environment, sustainable environment. Yeah, and then the questions that how to, because maybe in some area, especially in Indonesia or especially in rural area, that's maybe agricultural waste. Yeah, they just, what is the Priska, the term is just burn, for example.
Just or maybe burn.
Without any treatment, without any if we got the added value, no, just throw, it's useless or something like that. So in some activity that's collaborate also with ZESAM, or UNESCAP, one of United Nations organizations, that we conduct together the research, related how to treat the waste, especially agricultural waste, to become what is the biogas, maybe organic fertilizer, something. There are many that we introduce our farmer. The most important that we already conducted with our partner, international partner, and also our farmers, that the first thing that we have to break, or we have to change their mindset, farmer mindset, that what is we call that agricultural waste is what is we call that there are many some use added value. Yeah, we can use. Yeah, we cannot only throw or we can So this is the first thing, and then we introduce some technology. Yeah, appropriate technology. Yeah, and then the second, if we enlarge the area, and that's we want to make some increase the productivity, the efficiency, etc. So we introduce some technology, some smart technology. In our case, the first on the simple technology for field monitoring system. Yeah, now we have a collaboration with Myanmar in Japan. Yeah, I think Priska also in charge here. That's we install some sensor. For example, what is the sensor? Nitrat gas.
It's air emission sensors,
Air
probably
emission
carbon
sensor.
monoxide,
Yeah,
methane, and so on. Particulate matter also.
yeah, yeah. So yeah, of course, the contribution of our partner gave the grant to develop the multi-sensor. So the farmer or our community can see directly how dynamically the pollution, for example, and also our partner in Japan also can monitor. What is the situation at the environment? So that's the one of our technology, air pollution monitor. But if you have time, please come to Yogyakarta and we can work together. We can research together. I think there are many opportunities to give a contribution to our community and also, of course, our environment. That's my answer, Tajudin.
So I do understand. So basically, it doesn't matter at what stages, unless throughout the experiment, throughout the program, throughout the system, we implement the IoT. Is it?
Yeah.
Is it?
Yeah.
Yeah.
But the
Okay.
important things that you have to consider, you have to know first the behavior of our community. That's the
I
important.
see. Yeah. Yes. Correct. Yeah.
For example, the plastic, what is the waste, how to separate organic and unorganic.
Yeah.
This maybe this difficult point. That's how to separate its organic and unorganic something. Plastic. Where you come in Malaysia, in what university?
University Putra Malaysia.
Putra Malaysia.
Yeah.
Okay.
Yeah. Basically for agriculture, we are agriculture.
Nice. UPM Putra Malaysia.
UPM. I'm the student under this Dr. Haikal.
Okay. Yeah. There's many times that Dr. Haikal contact with us. Okay. Thank you.
Thank you.
Okay. Oh, yeah. Next October we will visit to UPM.
Yeah, sure. We can meet. We can.
Yeah.
We
Okay.
can discuss a bit. Okay, sure.
Good.
Actually, in this late Augustus, so
Oh,
we will
yeah.
also come to to UPM for Asian Agriculture Regional
ARC,
Competition,
ARC,
at UPM
Oh,
at
student regional. Perfect.
oh, I see. That's good.
Yeah, Mbak Priska will visit. Come.
I will go to UPM maybe in the next 2 weeks. And maybe for waste treatment, especially agriculture waste, for implementation IoT, it's not only just before research or maybe during the research or post the research, but we also have to know maybe what is the objective we want to implement the IoT, right? Because maybe IoT is also should be considered for human research, that not all of the people can use that, right? Or maybe can open that. So maybe we can implement that based on specific object, I think, maybe Prof. Lily and Mr. Tajuddin Sabri. Thank you very much for your question and
thank you.
insightful.
See you next time.
Okay, sure.
Thank you. Please, maybe Dr. Haikal also will deliver a
Oh, yeah, with
presentation.
regard to Dr. Haikal.
Yeah, in this afternoon.
Oh, yeah. Oh, okay.
Yeah, the third session from
Okay.
Dr.
Yeah.
Okay, thank you. Maybe we would like to also encourage all the participants to ask a question. Maybe if you would like to ask in Indonesia, it's
Oh, yeah,
okay. We
please.
would like
It's
to help.
better for me to answer in Indonesian.
Please, for all of the
Okay.
participants.
Yeah, until what time?
Okay, we are still have like 40
Mbak
minutes.
Mutia ada?
Yeah.
Mbak Mutia sehat. Okay.
Okay, maybe while we are waiting for other questions, I also would like to discuss further about the system, Prof. Lily. Maybe during our collaborations with the college, or maybe from the international or maybe international, I learned a lot that maybe in the system we are indirectly implemented this system previously, but how we would like to maybe optimize the system previously. And my question is that if we get the model maybe or the integrated smart agriculture that has been implemented, is there any maybe a periodic evaluation or maybe several aspects that we should maybe consider importantly?
Okay. Oh, it's like dissertation, eh? Okay, thank you, Mbak Priska. I think it's a good question that's related how to develop the model, because once again it's maybe different when we developing the model in non-agricultural sectors. It's very so. Always with my student, that's make what is research related to model development. I always mention or said that you have to consider the local characterization. Local characterization is very important, coefficient, because it's not a constant, it's a dynamic and different from the area to other area. Yeah, so when we build the model, mathematic model, something like that, we have to add one coefficient related to local characteristic. We cannot make the general model. Yeah? We cannot make a general model. Yeah? This is one point. That's if we are in agricultural field or in agriculture or biosystem field. So during we develop the model, we have to consider that there is a particular coefficient, important coefficient related to the area characteristic, or something location, something like that. Yeah, so the first, and the second, that's we have to know the agricultural system characterization. What is the dynamic? We cannot make assumption that agricultural component or agricultural factor is a static, always dynamic, depend on the time. So once again, it's almost that the pattern of agricultural component is non-linear. Yeah, so the Priska questions that we have many, or we have we cannot call the trial and error, but we have to make some validation. We have to test in one area to other area. So this is the pattern of our model, our system. So the first is one again, that's dynamic. depend on the time variant, and the second is we have to add one coefficient related the location characteristic. Yeah, so at least two. So if you have maybe next time you will make some collaboration or make some research related to agricultural system, you have to consider two important aspect. Thank you.
Okay, thank you very much, Prof. Lilik. It's it's triggering me to develop further,
Make you confused.
or maybe a bit confused also. So when we are talking about implementation of based on local characteristics and of course the dynamic of variation of time, maybe from your presentation, I would like to ask that, is there any maybe duration or time or maybe certain time that we can maybe assess that the model is run well, or maybe there are some outputs that we might assess probably?
Yeah, it depends, of course. If we talk about climate, yeah, weather, maybe more than 50 years we need to know or to understand the pattern of, for example, if we want to investigate the climate change, for example, yeah, we need the data from more than 20 years, let's say. But if for example, the cycles, the productivity or pattern of food crops, maybe not too many or not yet. The duration depend on the component of the system. Yeah, we cannot make okay, all the same. We need 10 years. No, yeah, we have to know that how the pattern of each component, the cycles of the component will change something.
Okay.
Okay.
So maybe it's about pattern, or maybe
Yeah.
for the food crop, and
Yeah.
I think. Okay.
Pattern, yeah. Okay.
Okay. Thank you, Prof. Lilik. We will also encourage other participants to ask the related questions. Or I think Prof. Lilik want to ask the question: what is the difference between Industry 4.0
That is the quiz.
in the
For
quiz?
all participation. all participation.
Yeah, because I see from the first beginning of the presentation, it's very clearly that we should understand the difference between 4.0 to 5.0.
Yeah.
Okay, I think maybe there are still no
No.
questions.
Or maybe it's already hungry.
Because it's quite
Okay, yeah.
interesting, and maybe for me it's a bit complicated to understand, because we have to understand many point of view, many aspects, and the system, it's not only just each by one, but just like your presentation is it's create like overlapping diagram and so on. Do you have any challenge maybe in the previous implementation program for our recommendation?
Yes, of course. There's in my slide, in my presentation slide, that at least there are three sample of location, in Yogyakarta, the second in Magelang, Central Java, and the third sample in Jawa Timur, East Java. Yeah, I think the challenge is how to sustain the program, because you see that if we change the mindset of our community, take time, I think. Yeah, we cannot only 1 year or 2 years. For example, maybe Mbak Priska also in charge in this program in Magelang. Yeah, our design to develop the smart agrotourism area, we need 4 years, both in human resource development, infrastructure development, institution, yeah, something like that. So I think, yeah, the most important is how to sustain. Yeah, if we focus only on infrastructure development, I think yes, we cannot guarantee that the program will sustain. Yeah. But in the first step, if we develop the human resource, yeah, to elaborate their knowledge, to elaborate their behavior, something like that, I believe that the program will sustain. I think that's our challenge, because not only talk about hardware, technology hardware, not only infrastructure, yeah, but it is a human knowledge, human behavior. So that's the challenge. Okay, thank you.
Okay, thank you, Prof. Lilik. So this is our GT together to ensure the
Yeah,
sustainability.
yeah. Okay.
So maybe I can maybe from the presentation and the lecture session in the first session, we would like to conclude some important points that the transition and the development of smart agriculture concept for integrated farming in Indonesia is not only for it's not only an advanced technology, but also a paradigm shifting in agriculture development to achieve food safety and environmental sustainability. And don't forget that the differentiation is that the concept of Industry 4.0 is a cyber physical system, and it should be combined to attributes such as tools, technology, instruments, like we know automation, connection, cloud computing, IoT, and so on. And maybe from the discussion and from the Q&A, I got important keywords that it should be not a smart technology only, but also an appropriate technology based on a local characteristics. And we should also optimize the research, the natural and or human research, although some challenge of the pros and cons between the integrated system of the farm. And maybe last but not least, we would like to implement and ensure that the smart system, or especially the smart agriculture of the integrated farming, is to ensure the sustainability. It's not only the technology, but ensure the sustainability by involving the human resources. Okay, thank you very much, Prof. Lilik, for such very inspirational and motivational.
Thank you very much.
In the end of the session, we would like to present our appreciation of certificate giving for the Dean of Faculty of Agricultural Technology for our invited speaker. For the operator or the committee, please show the appreciation.
T-shirt? Blue T-shirt.
Yeah, maybe the participants and the committees amazed with our very first session discussion.
Okay.
Okay. Mas Resnandia, can you help me?
Okay, Mr. Wait a minute.
Okay, no problem. Go.
Oh, I think it's in the wrong file. Yeah.
Yeah.
This is the
Thank
right
you.
file. We would like to say thank you very much for your time and for your insightful presentation in this summer course.
Thank you.
And also, thank you very much for inspirational insight. And we would like to give thank you, maybe not only thank you, but an appreciation for your time, Prof. Lilik.
Okay, thank you.
Thank you. Or maybe there are last statement from you, Prof. Lilik, for this session.
Yeah. Once again, that's the key success of our mission, related to smart agriculture. And not only in Indonesia, in every country, yeah, in Malaysia or maybe others, yeah, that's we need collaboration. The key success is collaboration. We cannot what is the individually or yeah one by one or something like that, yeah. We have to work together. We have to think together. It is my last comment. Thank you, and please welcome to UGM, to Yogyakarta, and we can discuss more detail. Thank you, Mbak Priska, and also Mas Reza.
Okay, thank you very much, Prof. Lily. Please give applause or maybe reaction to Prof. Lily. Thank you very much.
Okay, thank you. Okay.
Thank you.
Can we leave?
Yeah.
Miss,
Before that, maybe I will give it to the Master of Ceremony, Mr.
Oh yeah.
Nadia.
Okay, thank you so much for Professor Dr. Engineering Lilik Sutiarso, Master of Engineering, for the insightful lecture about implementation of smart agriculture concept based on integrated farming. Maybe there are several points that I can understand among the others, that we don't only need to develop the technology, but we also need to know the on-farm condition so that the technology becomes very effective. And then we need to change the mindset of the stakeholder of each supply chains to change the mindset from productivity to sustainability. So we are not only focusing on how much the input use and the output produced per period. Once again, thank you so much, Professor Dr. Engineering Lilik Sutiarso, Master of Engineering, for the useful material.
Okay, thank you. Welcome.
And also we would like to thank you to Dr. Priska Rinda Lestari, Bachelor of Engineering, IPM, who had led the discussion before. Because the appreciation certificate of Professor Lilik has been given by Dr. Priska, and then we move on to the next section. That appreciation certificate of Dr. Priska will be given by the chairman of the 5th Smart Agroindustry Summer Course Program, which is Mr. Makbul Hajat, Bachelor of Agricultural Engineering, Master of Engineering, PhD. To Mr. Makbul, please. Time and screen is yours. And the operator team can display the certificate for Dr. Priska Lestari. Okay, because there are something problem with the internet. Dr. Priska, I will recommend to wait 5 until 7 minutes because the internet is in problem. I'm sorry for the
It's okay, Mr. Resnandia Ganji Rangga Saptra, or Mas Rangga, I can call you.
yes, Rangga.
Okay, for such an opportunity. Thank you very much for to meet this morning, and we hope that we can learn together from the session, especially that from Prof. Lily, we get very insightful material and presentation that we can be developed for Smart Agroindustry 5.0. And thank you so much for the opportunity also for me. And please forgive or apologize for any inconvenience for the session. I hope it can be further discussion will be more interesting and will be more active in the next session. And also good luck for the implementation.
Okay, thank you so much, Dr. Priska. This certificate of being a moderator for this section with Professor Lilik. We will say thank you very much regarding the committee. We will say thank you very much for Dr. Priska and being moderator in this session. And then maybe we can have a little foto bersama mungkin ya. with
Okay,
all
before-
documentation.
Okay, before ending the first speaker session, let's take a photo together. For all participants, can you please turn on your camera, please, if you don't have no problem with your device or signal.
Okay, we will wait until 40 past 11 to all the participants that doesn't have the problem with the internet. You can turn on the camera because we will have an documentation.
Okay, so I will count from one. Okay, wait. I will count from 1, 2, 3. Cheese. Okay. Once again. 1, 2, 3. Cheese. Okay. Thank you.
Thank you very much for the master of ceremony community and all of the participants. Thank you, Prof. Lilik.
Izin meninggalkan room.
Okay, thank you so much.
Okay, as sounds in your